Hey everyone, Praveen this side. I hope you guys are doing well. So today we are going to solve transaction error, which is a classic level problem, right? And its difficulty is hard. But I'll try to make it as easy as possible for you. So let's read the description first. The description says the cost of stock on each day is given in an array price. Each day you may decide to either buy or sell the stock at the price of I. You can even buy and sell the stock on the same day. Find the maximum profit that you can get. So we have been given an array of prices on each day. Either we can buy or sell the stock at the price of I, and you can buy and sell the stock at the same price. So it's pretty self-explanatory. We need to find the maximum profit that we can generate. But there's a quick note point here. A stock can only be sold if it has been bought previously. So we can only sell the stock if it has been bought previously, which makes sense, right? And multiple stocks cannot be held on any given day. So it says the process should go as if you have bought, you need to sell, and if you have sold, you need to bought. Not unlike you have bought, and bought again, then sold, right? It should follow a process. If you have bought, you need to sell, and if you have sold, you need to bought, and if you have bought, you need to sell. So this is what note point says, right? Now we have understood the description. Let's dive into examples. So for example 1, the input for prices array is 100, 180, 260, 310, 410, 535 and 695, and then output is 865. Now the explanation says buy the stock on the day 0 and sell it on day 3. So if you buy on day 0 and sell it on day 3, the total profit generated is 310 minus 100, which is 210. Again, since we have bought and sell, again now it's chance to buy, right? So buy the stock on the fourth day and sell it on day 6 to generate a profit of 695 minus 40, that is 655. So the maximum profit is 210 plus 655, which gives the summation of 865, right? And here they have given a beautiful graph representation so that we can understand it more easily. So the stock has been bought here and sold here with the profit of 210, and again the stock has been bought here and sold here with the profit of 655. So we have understood the example pretty well. Now let's get into observations to observe few things which can help us in solving the problem. So let us consider this prices array. Now what is the intention? To maximize the profit, right? So to maximize the profit, what we can think of? We can think of being greedy, right? That is, we'll buy the stock at minimum price and sell the stock at maximum price, which will give us the maximum profit, right? So our intention is to buy at minimum and sell at maximum to get the maximum profit, right? That is, we are being greedy. Now let's start with day 0. Since in the past we have not bought anything, so let's buy this stock which is at minimum price of 1. So we have bought this stock at price of 1. Okay. Now we have reached on day 1. On the day 1 the price is 2, which is comparatively greater than 1, right? Now what the greedy nature says, just sell this stock. So we'll sell this stock at price 2. The profit we generated is 2 minus 1. That is, we bought at 1 and sold at 2. So the profit becomes 1. Okay. Again, since we have bought and sold, now we'll again try to buy it. So in the day 2, the stock price is 3, which is greater than any of the other stocks in the future, right? So we'll ignore it. Now we entered into day 3. In the day 3, we are getting a stock at 0 price. Okay, so we'll consider buying it. So we buy the stock at price 0 again. And on the day 4, the stock price is 2. That is, we bought at 0 and immediately on the next day, the stock price hiked up to 2. So we'll try to sell this stock. The profit that we generated is 2. Okay. Now in the whole journey, we have earned a profit of 1 and 2, which accumulates to 3. Right? So the total profit here is 3. Now you can think that the maximum profit that we can generate from this prices array is 3. But is it true? No. Because one mistake we did is on the day 0 we have bought the stock at price 1. Okay, which is correct. But immediately on day 1 we have sold the stock. Right? But if we had kept the patience and sold it on day 2, then the selling price would have been 3, which would have given the total profit of 2. Now, if we accumulate this whole profit, then we get the profit of 4, right? Which is greater than 3. So what mistake did we do? We were being greedy. We bought it at day 0 and immediately sold it at day 1. But if we have waited for one more day, then the stock price would have been 3 and the total profit would have been 2 for that day. Now, because of this, our greedy approach fails. Okay. One of my important learnings from my DSA journey is that whenever your greedy approach fails, you can blindly go on recursion. Try to take 2 to 3 examples and try to solve it through greedy approach. Now, from your 2 to 3 example, if any of the approach gets failed with greedy, right, that means you can directly think of solving by recursion. Okay. Now, when we were being greedy, we found that there is more optimal way to get the maximum profit, right? So here, so here in these cases, we can directly think of recursion. And what do we do in recursion? In recursion, we try to explore all possible paths, right? That is, we'll buy here, we'll sell here, 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 right? This way, there could be n number of combinations. We'll try to solve it by every combination, and from each combination, whichever combination gives us the maximum profit, right? We'll try to consider that profit. So let's consider this example again and try to find all possible paths. So here is the recursion tree for this array. I know seeing this tree is little overwhelming, especially for those people who are new to recursion. But trust me, it's very easy. So we'll start with index 0. That's what we have started. Now at index 0, we have two opportunities, either to buy this stock or ignore this stock. Okay. So that's what I did here. At index 0, I tried to buy this stock. Then the current profit for me will be minus 1. That is, I have burnt my minus 1 rupees from it. Okay. But if I ignore the stock, hoping that I could get it much cheaper in the future, I have ignored the stock, over then my overall profit remains 0, right? That neither I bought any stock nor I sold any stock. Okay, so these are the two possibilities, either to buy or to ignore. Okay, so suppose I have bought this stock here. Now since I have bought the stock here, there are two opportunities for me to be considered, either to sell the stock before buying any stock again, or let the buy stock be the same. Okay, hoping that in future you might get some better price. Okay, so at index 1, that is for this index, if I sell this stock, then my overall profit becomes 1. That is, I have bought at minus 1. That is, I have kept my money of minus 1, and at index 1 I have bought it at price 2. So the overall profit would be 2 minus 1, which is 1. That's what I have wrote here, right? So this is one profit that we get. Now since we have sold the stock, now we become eligible to buy. So here at index 2, I have bought the stock. That is, at index 2, I have bought the stock. So my current profit would be minus 3. Ignore this profit because this profit, till we reach the end of the index, will accumulate them all. Okay. So at index 2, we have again bought the stock and now we are in loss of minus 3. That is, we have kept the money from our pocket. Now suppose at this level we were in the profit of minus 1. Now we'll ignore this stock. That is, we let the buy stock be minus 1 only, right? Now here at index 2, we sold the stock. That is, at index 2, we sold the stock at 3 rupees. Okay, so the overall profit would be 3 minus 1, that is 2, right? That's what I wrote here. Now what do we understand by this? When we were buying at index 0 with price 1, we got a chance to sell it at index 1 with profit 1, and also got a chance to sell at index 2 with profit 2. So now this path gave me maximum profit, right? That at index 0 I have bought it, at index 1 I have ignored it, and in index 2 I have sold it. So the overall profit for me was 2. Okay. So this way the recursion works. That we have did two things, either to buy or not to buy. At every recursion step, we have done two things, either to buy or not to buy. We have bought here, so our profit was minus 1. But in this case, we have ignored our buying. But in this case, we didn't buy, so our overall profit remained 0, right? But if you have bought, you can do two things, either to sell the stock or let the buy be same, hoping that in future you can sell it at a better price. Okay, so we got the conclusion that we can buy at any index, but if we buy, we need to sell or let the buy be like that only. And similarly, if you want to sell, you can sell it at this position or at this position. That is, we are exploring all the possible opportunities. Yes. So these are the four steps that we need to follow. That is, if bought, sell it or hold it for future selling optimally. And similarly, if sold, buy now or buy in future at optimal price. That is as minimum price as possible to maximize your profit. Okay. So in this way, from this tree, the tree will continue till we reach the index 0, right? I have, since it get complex in this, since it get complex here, I didn't draw anything, but it will go and go till it reach index 4. Okay. Now from any path, let it be this path or this path or this path, from whichever path will get the maximum, right, will return that maximum. Simple. And when we explore this tree more and more, right, we can find so many repeating problems. So whenever we find so many repeating problems, right, we can cache them. That is, we can use dynamic programming. So dynamic programming is just a fancy word. Whatever you have computed previously, you just need to store it that so that you can use it for future use. I don't want to get deep into dynamic programming now. If you guys want me to make a video on dynamic programming, comment it down. I'll try to make it because this video itself is getting way longer. So we have understood the execution, we have understood the important steps. Now let's jump into the code. So this is our code in C++, although the logic remains same. So the function name is maximum profit and we have been given prices array, right? So firstly, I have taken the prices size and here we have called the function dfs with index 0 and false. Now what is this false? We'll see in the function. So this is our dfs function. So in the function we are passing two parameters. One is index, which is of type integer, and a boolean by. Now what does this signify? So with this by variable we can keep track that whether we need to buy it or sell it now. Okay, so this is the base case, that if we reach the end of the array, then there is no element, and if there is no element, then we return 0, right? And ignore this stuff for right now. So I created a variable profit. Now if the stock is already been bought, then as we discussed, we have 2 points, that is either sell it or hold it for future selling optimally, right? So here, ignore for best sell, that is we are ignoring it. From index I we move to index I plus 1, and if we have bought now, we are keeping that variable as true only so that we can buy it in future optimally. But if you want to sell right now, we are buying that, we are taking that prices at index I, and since we have bought it, right, we are making this variable as false so that we can say we are now ready for selling. Okay, now what will the profit? Now what will be the profit? The maximum of ignore for best sell and sell right now. And similarly, if it is not bought, then we would have come from any sell call. Okay, now if it is not buy, then we would enter into sell. Now in sell, what we have, either to buy now or buy in future at optimal price. So we are doing two steps. Ignore for best buying, that is we were selling, right? So we'll move at next index and keep the variables as false, that is we are still not ready for selling right now, we'll sell it in future. But if you want to buy right now, then take these prices. I'm taking the minus of prices because we are keeping this price from our pocket, right? So we are buying that and future ready for selling, right? And here too we are taking the maximum of ignore for best buy and buy right now. And from these four cases, whichever case returns the maximum, that's what we are returning it here. Okay, so this way we have smartly used the recursion. And remember, I told to ignore this part, and we can also ignore this part. We are actually using the concept of dp here. That is, we have declared a dp variable, that is we have declared a dp array of 2 dimensions, because here the two parameters are changing, right? Both index and by. So I've taken the 2D size DP, where we are creating n plus 1 size DP because I can go till n. And here the internal array size is 2 because for bool either it would be 1 or 0, right? And initialize it to -1. And here we are caching or memoizing. So firstly, at index I for by in the DP array, we are checking whether it is -1. When it would be -1? When no entry have been occurred here. But we are always updating our maximum profit here, right? In the cache that we have created, we are always updating it. So at any instance, if our cache is not -1, that means we have already computed it. So why to compute it again and again? So we are directly returning the cache. So basically this is the DP stuff. I know it's more overwhelming, but just understand the logic, right? Here, apart from our logic, we have just used 3 lines to cache the solution, right? But the main intention is to understand the logic. If you guys want me to make a video on DP, please comment it down. I'll try to make it and make your DP concept clear. Okay. Now, what will be the time complexity for this approach? For each entry, either we are for each entry either we are buying or holding the buy, and if we bought we are selling or holding the sell, right? So this will go exponential, so the time complexity would have been 2 power n. But since we use the DP and cache the solution, so our overall time complexity from a brute force recursion, which was O of 2 to the power n, comes to O of n, which is way more optimized, right? So the time complexity is O of n. And what would be the space complexity? Since we are using an extra DP array of n plus 1 size, and internally we are again using a vector of size 2, but we can ignore this because this is a constant array, right? So the overall space complexity will also become O of n. And remember guys, my main intention was to make you understand the logic. This DP stuff was not part of it, but to optimize the solution I have used it. You should definitely be learning about DP, and if you want to learn it from me, again comment it down. If I get good number of comments in the comment section, I'll definitely make a video on it. So yeah, this was the video. If you guys like this video, please like, share and subscribe. And if you have any doubts, be it DP also, comment it down. I'll try to respond as quickly as possible. And if you guys want any improvement in my teaching, please comment it down so that I can get clarity on that and better work on it. So see you guys tomorrow solving any other coding problem. Till then, stay safe, stay healthy, and peace.